Hey, thanks for clicking on this video. If you want to follow along, the links to the companion worksheet are in the description below. So today we're evaluating summation notation. So anytime we see summation notation, you're going to see this Greek capital letter sigma. And then you're going to have some things below, above, and next to it. Now what's below it is the first number we're going to plug in, and the top number is the last number that we're going to plug in. And off to the right, this is the expression that we're going to plug into. So this is saying start at n equals 1 and plug that in for n here. Okay? So that's going to be 4 times 1. Now the s for sigma means that we're going to find the sum. So onto 4 times 1, we're going to add, well, now plug in the next number, 4 times 2. And so we're going to plug in every number from 1 up to 6. So 6 is where we stop. So 4 times 3 plus 4 times 4 plus 4 times 5 plus 4 times 6. And so we want to find this sum. Now one thing to make the computation a little easier is there's a 4 in all of these, so I can take that out. So if I factor that out, I'm left with 1 plus 2 plus 3 plus 4 plus 5 plus 6. And if I pair up 1 and 6, that gives me 7. If I pair up 2 and 5, that gives me 7. If I pair up 3 and 4, that gives me 7. So this is 4 times 21. So we get a total of 84. Now for the second one, notice that we have different letters from number 1. Number 1 had N, number 2 has K, and that's all right. You can have different letters, doesn't really change much. But you got to pay attention to what number you're starting with when you plug in. Here we're plugging in with 5, and we're going to end with 8. And a lot of students get confused by this because they often think that 8 is how many terms there are. No, 8 is the last number you plug in. In this case, 5 is the first number you plug in. So we plug in 5, and that's squared, plus 6, and that's squared, plus 7, that's squared, plus 8, and that is squared. So we have 25, plus 36, plus 49, plus 64. Now if I pair up 36 and 64, that adds up to 100. And if I pair up 25 and 49, that's 74. So we get a total of 174. Number 3, here we're plugging in 1 to start with, and we're going to end up with 50. And we're going to plug into this. Now what's weird is there's no n. And students often get worried about this because, well, there's nothing to do. Well, if I plug in 1 in for n, what do I get? I get 6. What if I plug in 2 in for n? I get 6. If I plug in 3 in for n, I get 6. Well, this is going to happen even if I plug in 50 in for n, I'm going to get 6. So basically what this means is that I'm taking 6 and adding it 50 times. Well, we can simplify that by taking 6 times 50. And that gives us 300 for our total. Now here, we want to find this sum. We start with 1, and we're going to plug in all the way up to 100. So if I plug in 1 in for this, and now we're using K, 3 times 1 minus 7, that's going to be negative 4. If I plug in 3 times 2 minus 7, that's going to be negative 1. 3 times 3 minus 7 is 2. Now I plug in these 3 because this tells us what kind of series it is. In this case, we're dealing with an arithmetic series, because to go from -4 to -1 and -1 to 2, we're adding the same number. which we call the common difference. The common difference is 3. And so since we have an arithmetic series, what I need to do is I need to find the last term. So 3 times 100 minus 7, so that's 300, and then 300 minus 7 is 293. And so the formula for an arithmetic series is we take the number of terms divided by 2, and then we add the first term and we add the last term. Because if I pair up all the numbers in between, they're all going to add up to the same thing. So that's going to be 50 times 289. And if we use a calculator real quick, we get a total of 14,450. Now here for number 5, here we're plugging in 0 for our first term. So it's 6 minus 0.1 times 0, which is 6. Now we plug in 1. 6 minus 0.1 times 1, so that's 5.9. Then we plug in 2. 6 minus 0.1 times 2, and that's 5.8. So here again, to go from term to term to term, it appears that we are going down by the same amount. It appears that we're going down by 0.1. That's our common difference. So again, we have an arithmetic series. So to find the sum, what I'm going to need to do is I'm going to need to find the last term. So I'm going to need to plug in 1,000. So 6 minus 0.1 times 1,000. And so that's 6 minus 100. And I get negative 94. So now I want the sum of these terms. Now here's the thing to be aware of that a lot of people mess up on. In this one, we started with 1 and ended with 100. So there were 100 terms. But here we're starting with 0. So there aren't 1,000 terms. There's 1,001 terms. And so the first term is 6. And the last term is 94. And if I take 6 minus 94, I get negative 88. And I can divide the negative 88 by 2. And so I get negative 44,044 for my total. So on to the last page. Here, we're plugging in 1 all the way up to 20. So negative 2 to the first is negative 2. Negative 2 squared. Remember that when we square a negative, it becomes positive. So it's plus 4. Negative 2 to the third is negative 8. So here we're not adding the same number. Here we are multiplying. This is a geometric. And so the R, the common ratio, is negative 2. And so in order to find this total of these 20 terms, because that's how many terms there are going to be, if I plug in 1 and end at 20, that's how many we'll have. I need the first term, negative 2, minus the first term times the common ratio to the nth power. So that is the number of terms, all over 1 minus the common ratio. And so we'll do this on the calculator. And we get a total of 699,050. So this is the formula for a finite arithmetic series. That's the first term, that's the first term, that's the common ratio, that's n, and that is the common ratio there. Number 7, here we're starting with 1 and going to 6. So we plug in 1, so 20 times 1/3 to the first, so that's 20 over 3. Then the next term, 20 times 1/3 to the second power, so that's 20 over 9. And then we have 20 times 1/3 cubed, so that's 20 over 27. And so when people see this, they often confuse the fact that we're not multiplying by 3, but we are in the denominator. So what that means is the denominator is getting multiplied by 3. So we're multiplying by 1 over 3. That's what's going to cause the denominator to get bigger. And the one way you could notice that is if you look at what's carrying the exponent, this is your common ratio, just like it was here for this one. Whatever's holding up the exponent, that's your common ratio for a geometric sequence or series. So here we want to add up the 6 terms because we're going from 1 to 6. So S6, so our first term is 20 over 3 minus the first term, 20 over 3, times 1/3 to the 6th, all over 1 minus 1/3. And so as we make this calculation, remember to be using parentheses a lot, because if you don't, you might end up with a weird fraction. So the exact fraction is 7280 over 729, or if you prefer a decimal approximation, you get 9.986. And then the last one, number 8, we're starting with 1, but here we're going to infinity. So that means we're not going to stop plugging in numbers in for n. So we start with 3 over 10 to the first, which is 3/10. Then we have 3 over 10 squared, which is 3 over 100. Then we have 3 over 10 cubed, which is 3 over 1,000. And we're not going to stop. And so what is the common ratio? Well, it's the denominator that's getting multiplied by 10. So our common ratio is 1/10. Now, when we have a geometric series that is infinite, our formula is the first term, 3/10, over 1 minus r, 1/10. So 3/10 is on top and 9/10 is on bottom. So when we divide fractions, we take the second fraction and multiply by its reciprocal. And the tens will cancel out. So we're left with 3 over 9, which is 1/3. And there's our total. Thanks for watching. If you liked that video, hit the like button. If you want to see more videos like that, click the subscribe button. To support the channel, click the links in the description down below. Thanks for watching, and remember, the best way to understand something is to do it.